In section 4.7, we're going to talk about some counting rules. So how to kind of, in more complicated situations, how to find out how many things are in our sample space. So we're going to start out with what's called the fundamental counting rule. So this says given two trials, the first trial can have m different outcomes, and the second trial can have n different outcomes. Then together, the two trials can have m times n different outcomes. Okay, so if you know how many the first has, it's m, whatever number that is. And the second one has n. You just multiply them together to get the total number. So this is helpful for finding the number of items in your sample space. Okay, so we're going to use the fundamental counting rule to find the total number of outcomes for flipping two coins. Okay, so for the first coin flip, there are 2 outcomes. And for the second coin flip, there's 2. So that means there's a total of 4. So instead of writing off the tree, we can just use this to find out how many there are. And rolling 2 dice, well, for the first dice, so it means just normal dice, we've got 6. And for the second one, again, we've got 6. So that's a total of 36. Okay. So flipping a coin and rolling a dice, well, flipping a coin, we'd have 2 outcomes, either heads or tails, and rolling a dice, we'd have 6. So that gives us a total of 12. Okay, and we can use this for more than 2 trials. So this says we want to randomly guess the 4-digit number, PIN number of a friend. So there's 10 digits, 0 through 9. So the first digit, there are 10 possibilities. The second digit, there are 10. The third, there's 10. And then the fourth digit, there's also 10. So here we have 10 to the 4th possibilities for pins. Or 10,000 possibilities. So this means if we want to know the probability of randomly guessing, if we just randomly pick one number, we'd only have a 1 out of 10,000 chance of randomly picking a number. Okay, now we're going to look at a similar problem about license plates. So it says, given the newer Ohio car license plates that have 2 letters followed by 3 digits by 2 letters, what's the probability that a random Ohio car has license plate with this specific license, HC290LB? Okay, now we know there are 26 letters, A through Z, and 10 digits. Okay, so to figure out how many different license plates they can even make with this, license plate way they do it, numbering scheme. Well, the letters, every place there's a place for a letter, we have 26 possibilities. And any place there's a digit, we've got 10. So to find the total number of license plates, we're going to take 26 times 26 times 10 times 10 times 10 times 26 times 26. So here we get this very large number. So 456,976,000 license plates. So the probability of selecting this one very specific one would be 1 out of 456,976. 000. Okay, so, just randomly selecting one, it'd be very unlikely to find that exact license plate. Okay, now another thing we're going to see is the special notation, an exclamation point. Okay, so it looks like the numbers are excited, but it's just a new thing called a factorial. And it means we take the numbers and multiply kind of going down. So 3 factorial means we take 3 times 2 times 1, which gives us 6. 7 factorial means we take 7 times 6 times 5 times 4 times 3 times 2 times 1, which gives us 5,040. And so 5 factorial would be 5 times 4 times 3 times 2 times 1, which would be 120. Now your calculator will actually do this for you. Okay, and there's the very last page of these notes are instructions on how to do kind of the stuff in this section on the calculator, and I'll also make a video. But to do this, you're going to hit the math button. Okay, when you hit the math, there's a menu at the top, and the fourth one, if you arrow all the way over to PRB, that's the probability menu. Okay, and then number 4 is an exclamation point for our factorial. So you'd want to put in your number first on your home screen. So, for example, for the 5 factorial, you put in 5, then you do math, arrow over to probability, and then hit the number 4. That'll take you back to your home screen with 5 factorial. Okay. Now, one thing we have to be aware of is 0 factorial. This is a special rule that 0 factorial has to equal 1, and we'll see that's important so that we're not dividing by 0 in some places. So 0 factorial is special. Okay, now the factorial rule says if we have n different items, it can be arranged n factorial different ways. Okay, so if we look at the next page, it says how many different ways could you go to McDonald's, Taco Bell, and Dairy Queen? Okay, so here we have 3 different restaurants. Okay, and the way of actually arranging this, the special math word is called, we're permutating them. So the way they could be arranged are permuted in 3 factorial different ways. Okay, so that means there's a total of different ways, 6 different ways that we could visit those 3 restaurants in order. So for example, we could go McDonald's, Taco Bell, or Dairy Queen. Then we could go McDonald's, Dairy Queen, Taco Bell, and so on and so forth. Okay. So different ordering arrangements are called permutations, our special math word. Okay, so the next one says, if you want to take statistics, English, computer, and science, in how many different ways could you take these 4 classes? So these are 4 different things. We've got 4 factorial, so 4 times 3 times 2 times 1, or 24 different permutations, or ways you could arrange those. Now, if we only wanted to take 4 of those classes, well, how many classes could we put in the first spot? Well, there's 4 different classes we could take. So 4. Now, after we've already picked one of the classes, in the second spot, there are 3 classes we could take. And then in the third spot, there are 2. Okay, now, that means we're going to be leaving 1 class out. And so again, this gives us 24 permutations, even though you're leaving a class out. Okay, now this says, how many different 4-letter words can you make from the name Walt Disney? So we need to count how many letters are in Walt Disney. If we count, there are 10 letters. Okay, so the first letter, there would be 10 possibilities. For the second letter, there would be 9 possibilities. For the third letter, there would be 8. And for the fourth letter, there would be 7. So we take 10 times 9 times 8 times 7. And we get 5,040 permutations. Okay, so the probability of randomly choosing the word Neal, N-E-A-L, would be 1 out of 5,040. Okay, so now we're actually going to have a formula to use permutations. So, when all the items are different, if we want to select R items from a group of N different items. So we have an N items total, and we want to pick R of them. So for example, before we had 4 classes, and we wanted to choose 3 of them. Okay? So we want to find the number of permutations we can have. And the formula for N, we said NPR. So permutations where we've got N items and R things. Formula is N factorial divided by N minus R factorial. So 5p5, our N is 5 and our R is 5. So we're taking 5 factorial divided by 5 minus 5 factorial. So this is the same as 5 factorial over 0 factorial. And remember, this is why 0 factorial is equal to 1. So this gives us 120 over 1, or 120. Okay, now 4p3, Our n would be 4 and our r would be 3. So we get 4 factorial over 4 minus 3 factorial, or 4 factorial over 1 factorial, which would be 24 over 1, or 24. And then if we want to do 22p5, our n would be 22, our r would be 5, so we'd have 22 factorial over 17 factorial. And if you do this in your calculator, it gives you 3,160,080 different arrangements. Okay, now you can do NPR on your calculator. So to do this, you would put in your n, whatever that number is, and then you would hit math. You would go over to PRB, just like you did for factorial. Okay, and then number 2 says NPR. So you would choose NPR. That will take you back to the home screen, and you'll put in your R value. Okay, then you would hit enter, and it will give you the permutations. Okay. So it says we have 20 students in the class. And how many different ways can we choose 5 students to be the class president, VP, treasurer, social coordinator, and tutor? So here we're arranging them in these different offices. So we have 20 students. We're permuting them, and we're choosing 5. So 20p5, which you can do in your calculator. Okay, so we get just for these 5 offices and only 20 students, there are 1,860,480 ways that these offices could be chosen. Now, the idea with permutation is that the order really matters. So what order you're putting things in. For example, with the last example, we had different offices. If you just pick 5 people, they want to know which person is president and which person is vice president. So the order there of how you're choosing them matters. Okay. So our next one says, a new author would like to set up book signings in a major city of each state, but only has time to visit 5 states. How many possible routes can she take? So she's going to 5 different places. What's the way she can arrange those 5 stops? So this would be 5p5, okay, which is actually the same as 5 factorial, because you get 5 factorial over 0 factorial, which is just 5 factorial over 1. So there's 120 ways she could make this trip of 5 cities. So permutations get big pretty fast. Now, sometimes it repeats, different things repeat, and we have to use a different rule. So if we have n total items, and then we have different ones that are repeating, we take n factorial divided by, and then a factorial of how many something is repeating each time there's something repeating. So, for example, it says, how many different ways can we arrange the letters in the word keeper? So first we count how many total letters there are. 1, 2, 3, 4, 5, 6. So 6 factorial over, now we've got e's repeating. There are 3 e's. So divided by 3 factorial. So this gives us, again, 120 different ways. Now, if we want to talk about how can we arrange the letters in the word Mississippi, well, in Mississippi, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we've got 11 different letters, okay? Then in our denominator, well, we've got 4 I's repeating. We've got 4 S's repeating. And we've got 2 P's repeating. Now, when you put this into your calculator, you want to put parentheses around your denominator. So you're going to put 11, and then get the factorial, divided by, and then put parentheses. And do 4 factorial, 4 factorial, 2 factorial, and then you'll close your parentheses and hit enter. So the way we can arrange the letters in the word Mississippi, we've got 34,650 different ways. Okay, and then our last one, it says a family has 5 children, 3 boys and 2 girls. How many different ways can they be born? Okay, so we've got 5 children. We're repeating 3 boys and 2 girls. So we're going to divide by 3 factorial, 2 factorial. Remember to put that in parentheses. So in your calculator, this should look like 5 factorial divided by, open up your parentheses, 3 factorial, 2 factorial, close your parentheses. So this gives us 10 different ways they could be born. Okay, so as we've said in the previous examples, the order of the items mattered. Now, what if the order doesn't matter? We just want to pick groups. So if we just want to pick groups of things, this will actually decrease the total number of groups possible. And these we're going to call combinations. Okay, so the combination rule says if we have n different items and we're selecting r of them, so just like the other case, but the order doesn't matter, then the number of combinations we can make is n factorial divided by r factorial times n minus r factorial. So if we have 5c5, our n is 5 and our r is 5. So we're taking 5 factorial over 5 factorial, 0 factorial, and this just gives us 1. If we have 4c3, so our n is 4 and our r is 3, we have 4 factorial over 3 factorial, 1 factorial, and this is just going to give us 4. And if we have 22c5, we have 22 as our n and 5 as our r. So here we're taking 22 factorial over 5 factorial, 17 factorial. And this gives us 26,334. Now, just like with permutations, you can do NCR on your calculator. You put in the N, and then you do math, go over to PRB, and number 3 is NCR, and then you'll put in your R. Okay, so this says we've decided to select a committee of 3 members from this statistics class. How many different combinations of 3 students can you make from the class? So now a committee, it doesn't matter what order the committee's in, they're just a group of people. It's a little different than having offices like president, vice president. So here, we're just going to assume whatever class this video is for, we have 25 students. Okay, so normally if this was a regular class, I'd pick out some names, like what's the probability that the committee will consist of Emily, Steve, and Joe, or whatever. So, but the names really don't matter. We can just say, what's the probability it's some specific student 1, student 2, and student 3. Well, first we need to find out how many different committees there can be made, and that would be 25C3. So a good way to remember that committees are always combinations are because they both start with C. So if we do 25C3 on our calculator, we get 2,300 different ways. So that means for 3 specific students to be chosen for a committee, that's a 1 out of 2,300 chance. So the next one says 7 musicians are sitting at a table. 3 of them play the saxophone. If you randomly choose 3 of the musicians, how many ways can you choose 3 that should be saxophonists? Okay, so we're just choosing, 3 musicians out of 7. So this would be 7C3, which gives us 35 ways. So since there's only one group of 3 saxophonists, the probability would be 1 out of 35. Okay, this is a combination problem because it doesn't matter which order you choose the musicians in. To make the group. Oh, sorry, I got ahead of myself. This problem was right. We want to know how many ways could we choose 3 musicians. Now, this next part was answering this question. What's the probability that the 3 you choose are the ones who play saxophone? Since there's only 3 that play saxophone, we'd have 1 out of 35. Okay, so now we're going to do a bunch of problems kind of as practice. So the first one says, if a family has 10 children, how many ways can these 10 children just be born? So just girls or boys. You don't know how many girls or boys you have. So the first one could be either girl or boy. So there's 2 possibilities. The second one, there's 2 possibilities. Third, 2. So we'd have, for each kid, we'd have 2 possibilities. So 2 times 2 times 2 times 2 times 2, 10 times. So this is the same as 2 to the 10th. Or 1,024. Now the next problem, it says if a family has 10 children, 4 boys and 6 girls, how many different ways can these children have been born? Now this is like the Mississippi example. We've got 10 total children. Okay, so 10 factorial, we're repeating 4 boys and 6 girls. So we have 10 factorial divided by 4 factorial, 6 factorial. So here there are 210 different ways those children can be born. Okay, number 3 says a farmer has 10 trees, each a different species. How many different ways can these trees be planted in a row? Okay, so in a row means that the order matters. So this means it's a permutation. Okay, so we've got 10 trees, we're permuting them, and we're going to plant all 10 of them. So this is 10p10, which is there'd be 3,628,800 ways to plant these trees. Now here, the next one, it says the farmer has 10 trees. 5 of them are maples, 3 are oaks, and 2 are buckeyes. How many different ways can these be planted in a row? So now, again, we've got repeating. So it's like number 2. We've got 10 trees, so we do 10 factorial, divided by the 5 maples, repeating, the 3 oaks, and the 2 buckeyes. So remember, we want to put parentheses around our denominator. So here there are 2,520 ways to plant those trees. Okay, number 5 says 7 people were in a race. Okay, how many different ways can we present awards for first, second, and third place? So here, especially the person who wins thinks the order definitely matters. So again, we're going to use permutations here. So there were 7 people in the race, and we're placing 3 of them. So this is going to be 7p3. So there are 210 different ways that you could place them. Now the next one's a little different. It says, find the probability of selecting 5 winning numbers from the numbers 1 through 27. Now if we're just selecting numbers, we're not ordering them, this is going to be a combination. Okay, so this would be 27C5. So we'd get 80,730. So the probability of choosing 5 winning numbers would be 1 out of 80,730. Okay, so number 7 says when testing for a current in a cable with 7 color-coded wires, the wires need to be checked in pairs. How many different tests are required to check every possible pairing of 2 wires? So since you're just putting 2 wires together, it doesn't matter which wire you put in your hand first and which one second. So this is like another combination problem. So this is going to be 7C2 or 21. Okay, and our last problem says there are 12 members on the board of directors of a large company. So part A says if they must choose a chairperson and a secretary, how many different slates are possible? So how many different ways could you choose these 2 people? Now for this, order does matter because whether you put Bob as the chairperson and Joe as the secretary, or Joe as the chairperson and Bob as the secretary, they're different. So the order matters. So this is a permutation. We've got 12 different people we're choosing from, and we're choosing 2. One for the chairperson and one for the secretary. So 12P2 gives us 132 different ways. Now part B says if they must form an ethics subcommittee of 4 members, how many different subcommittees are possible? Now subcommittees, it doesn't matter who was on the committee first, you're just choosing them. So this is combinations. So this would be 12C, and we're choosing 4 members for the committee. So we've got 495 committees there possible. Okay, now the last page just is kind of a reminder for you of how to use your calculator for factorials, permutations, and combinations. So remember, factorial, all of these are you're going to the hitting math and then arrowing over to probability. Okay, so factorial is number 4 under the probability menu. Permutations is 2, and combinations is 3.